Let's look at some more examples of solving a system of linear equations by graphing. Let's look at our first example. 7x plus y is minus 17. 3x minus 10y is equal to 24. So here are steps. Steps is to graph the first line. Graph line number 2. 3. See or estimate where they cross. A lot of people teach it, and a lot of people do it, is that you rewrite both of these equations as y equals mx plus b. You don't have to. You can graph it any way you want to. You just have to graph them. So let's look at the first one here. 7x plus y is equal to minus 17. I'm going to rewrite it y equals mx plus b, so I subtract 7x, and I get y is equal to minus 17x minus, y is equal to, oops, my bad, y is equal to minus 7x plus 17. And then the second equation, 3x minus 10y is equal to 24. Then I get minus 10y is equal to minus 3x plus 24, right? What I'm going to do is I'm going to subtract 3x from both sides, and I'm going to divide by negative 10. And I get y is equal to, that's 3/10x plus, now 24 over 10, normally I would simplify that so that that would be 12 over 5. But because we're going to graph it, I'm going to write that as a decimal. So my general rule is I generally keep it as improper fractions unless I'm going to graph it. So that's 2.4. This one's going to be a little bit hard to get exactly right simply because it's a big graph, but you get the general idea. And if you wanted to get the exact answer, you would use a calculator. So we're really doing this to understand how this works. Let's graph this. Draw on your x and y graphs. You have to use a ruler. It doesn't count if you don't use a ruler. So our first line is y is equal to minus 7x plus 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, right there. Just barely fits. And then you get minus 7. So that's 1, 2, 3, 4, 5, 6, 7 over 1. And I'm going to do that again. 1, 2, 3, 4, 5, 6, 7 over 1. Now you don't need to draw more than 2 points. It's just, I'm just trying to get a little better sense of what the line looks like. There's my first graph. Y is equal to minus 7x plus 17. And my second line is y is equal to 3/10x plus 2.4. So I'm going to go to 2.4. 1, 2.4 is about right there. The slope is 3 over 10. So that's 1. You have to be careful there. If I start at 2.4 and I go up 3, that's 5.4. 1, 2, 3, 4, 5.4 is right there. And then I go over 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here you're really only going to get an approximate answer. There's your solution, your estimated solution right there. What's that going to be? That's going to be 1, 2, 1, 2, 3. I think that's going to be 2, 3. Whether it turns out that's a good or bad estimate really depends on how well you're going to draw your lines. That's how you solve by graphing. Let's do one more quick example. This one I just want to show you that sometimes it's given to you in y equals mx plus b, 5x plus 2, y is equal to 3x. We have to think about what y equals 3x means. That's the same as y is equal to 3x plus 0. And it's not hard, it's just want to make sure you have seen that. You just graph the two lines. 5x plus 2. The y-intercept is 0, 2. Right there. The slope is 5, or 5 over 1. 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 1. So I'm going to graph these two lines. That's y is equal to 5x plus 2. After you graph the first line, you can graph the second line. It's y is equal to 3x. That's what's the problem. It's y equal to 3x. But y equals 3x is the same as y equals 3x plus 0, which means you start at the y-intercept at 0. Or 0, 0. And your slope is 3. 1, 2, 3 over 1. 1, 2, 3 over 1. This one's going to be pretty hard to see where it is. It looks like to me the point is about right there. 1, 1, 2, 3. It looks like to me that's minus 1 and about 2.5. And that's how you graph those two lines. And that's how you graph, that's how you solve systems of linear equations when you graph. The next video has to do with trig problems, and there's actually two types of trig problems. They're not really tricks, but you want to think about it that way. That is when lines are parallel or when they're the same line. So when you have parallel lines or when you have the same line. And that's what the next video will tell you.